Now this is the code for a FIFO with dual clock. Now if you have not understood what a FIFO is, you please check my other video where I've explained a basic FIFO and a FIFO with a single clock. So here we look at FIFO with dual clock. That means there is a separate clock for writing. So let's call that clock write, and the separate clock for reading. So that is clock read. So your FIFO is the same inside, but just that you are using different clocks. So these two clocks are independent. That means your clock write can happen independent of your clock read. So there is no dependency on both the clocks, and you can have two different frequencies, say 17 kilohertz or 77 megahertz. So you can have any frequency reading and writing into the FIFO. So let's look at the code. So the only difference here from the previous code that we saw is that you have two different clocks. You have a read clock and a write clock, and the definitions remain the same. And your first always block, there is no change. So we just give the status bits, that is buffer empty and buffer full, based on your FIFO counter, right? And right. So now we have to start splitting our blocks. We can't keep things in the same block. So if you look at this, your FIFO counter is being updated in two different blocks. Now, the one thing you have to remember is there cannot be any conflict, meaning if always block 1, say this block and this block have the same condition occurring and FIFO counter is getting two different values, then there will be a conflict. Now just avoid that kind of coding, then you're fine, right? So the first block, the first always block, enters because of clock write. So that is when you want to write, right? So at the clock edge or at reset. So we come in. So if you've noticed, reset is given only in one place. The asynchronous reset is not given here, right? So at reset, we reset the FIFO counter, and if it is not because of reset that we've come in because of the write clock, then we check for the write enable signal. If write enable is 1 and we are able to write into it, that means buffer is not full, then your FIFO counter is incremented by 1. Else we keep the FIFO counter as it is. In the second always block, we come in because of read clock, and we check if read enable is 1, and if you are able to read, that means your buffer is not empty, then we decrement the FIFO counter. Else we keep the FIFO counter as it is. Now if your write clock and your read clock come at the same time, say for example your write clock is here and your read clock, although they are two different clocks, they happen to come at the same time, then there will be a conflict in this line and this line. So if you expect that the clocks could come at the same time, then it's better to remove these two lines. So you can remove the else case, and so that will be inferred by the synthesis tool that you want to hold the FIFO counter. Right, the next two always blocks will help reading and writing into the memory. So let's look at them. So this is for reading and this is for writing. So we come inside this always block because of your read clock or your reset. At the reset, we send 0 to buffer out. If it is not because of reset, we check for read enable. If you are able to read, that means buffer is not empty. Then you use the read pointer, that is the tail pointer, and read from the buffer memory, put it out at data out. If not, you keep data out as it is, buffer out as it is. Right, so the next always block is for write, and at the write clock, you come and check for write enable, and if you are able to write, that means buffer is not full, then you use data in, the buffer in, to write into your memory using the write pointer address. Write pointer is the head. Else, you just keep data as it is. You don't actually do anything. Right. So the next always block is for managing write pointer and read pointer. So this again is split into two. So at the write clock or reset, you come in and you reset the write pointer if reset is active. If reset is not active, then if write enable is active and your buffer full is not 1, then you can increment and go ahead right into the FIFO. So then you increment the write pointer, else you keep the write pointer as it is. So in all these cases, your else is optional. You can just omit it and it will be inferred, like we saw how to design a latch. And your clock read clock will help you read. So if reset is active, you reset the read pointer. If it's not active, and if read enable is 1 and your buffer is not empty, then you increment the read pointer. This is the tail pointer. Else you keep read pointer as it is. So this is how we write the code for FIFO, which has two different clocks, the read clock and the write clock.